Class 10, Chapter 4, Quadratic Equations. An algebraic expression of the form p of x equal to a0 plus a1x plus a2x square plus a3x cube plus anx raised to n, where a not equal to 0 is called a polynomial in variable x of degree n. Here a0, a1, a2, a3, an are real numbers and each power of x is a non-negative integer. Example, 3x square minus 5x plus 2 is a polynomial of degree 2. 3 root x is not a polynomial. Reason, power of x is 1 by 2, which is not a whole number. X square plus x raised to minus 1 plus 6 is not a polynomial. Reason, power of x is negative 1, which is not a whole number. 6 is a polynomial. Reason, 6 can be expressed as 6x raised to 0. 0 is a whole number. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial. For example, 4x plus 2 is a polynomial in the variable x of degree 1. 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. Types of polynomial. 1. A polynomial of degree 0 is called a constant polynomial. Example, 6x raised to 0. 2. A polynomial p of x equal to ax plus b of degree 1 is called a linear polynomial. Example, 3x plus 9. 3. A polynomial p of x equal to ax square plus bx plus c of degree 2 is called a quadratic polynomial. 4. A polynomial p of x equal to ax cube plus bx square plus cx plus d of degree 3 is called a cubic polynomial. 5. A polynomial p of x equal to ax raised to 4 plus bx cube plus cx square plus dx plus e of degree 4 is called a biquadratic polynomial. Quadratic equation. A polynomial p of x equal to ax square plus bx plus c of degree 2 is called a quadratic polynomial. Any equation of the form p of x equal to 0, where p of x is a polynomial of degree 2, which is a quadratic equation. Example, 2x square minus 3x plus 2 equal to 0 and x square plus 5x plus 6 equal to 0 are quadratic equations. Methods to find the solution of quadratic equations. There are 3 methods to find the solution of quadratic equations. First one, factorization method. Second, method of completing the square. And third, quadratic formula method. Factorization method. Steps to find the solution of given quadratic equation by factorization. First, write down the quadratic equation in standard form. Ax square plus bx plus c equal to 0. Find two numbers alpha and beta such that sum of alpha and beta is equal to b and product of alpha and beta is equal to ac. Write the middle term bx as a alpha x plus beta x and factorize it by splitting the middle term and let the factors be x plus alpha and x plus beta. That is ax square plus bx plus c equal to 0 gives x plus alpha into x plus beta equal to 0. Now, equate each factor to 0 and find the values of x. These values of x are the required solutions of the given quadratic equation. Illustrative example. Solve the following quadratic equation by factorization. X square plus 6x plus 5 equal to 0. X square plus 5x plus x plus 5 equal to 0. X into x plus 5 plus 1 into x plus 5 equal to 0. X plus 1 into x plus 5 equal to 0. X plus 1 equal to 0 or x plus 5 equal to 0. X equal to minus 1 or x equal to minus 5. Illustrative example. Solve the following quadratic equation by factorization. 8x square minus 22x minus 21 equal to 0. 8x square minus 28x plus 6x minus 21 equal to 0. 4x into 2x minus 7 plus 3 into 2x minus 7 equal to 0. 2x minus 7 into 4x plus 3 equal to 0. 2x minus 7 equal to 0 or 4x plus 3 equal to 0. X equal to 7 by 2 or x equal to minus 3 by 4 are two roots of the given equation. Illustrative example. Solve the following quadratic equation by factorization. X square minus 8x plus 16 equal to 0. X minus 4 whole square equal to 0. X minus 4 into x minus 4 equal to 0. X minus 4 equal to 0 or x minus 4 equal to 0. X equal to 4 or x equal to 4 are two equal roots of the given equation. Illustrative example. Solve the following quadratic equation by factorization. X square minus 9 equal to 0. X minus 3 into x plus 3 equal to 0. X minus 3 equal to 0 or x plus 3 equal to 0. X equal to 3 or x equal to minus 3 are roots of the given equation. Method of completing the square. Steps to find the solution of the given quadratic equation by the method of completing the square. Step 1. Write the given quadratic equation in its standard form. Ax square plus bx plus c equal to 0 where a not equal to 0. Step 2. Make the coefficient of x square unity by dividing all the terms by a. If a is not unity, then we get x square plus b by a into x plus c by a equal to 0. Step 3. Shift the constant term c by a on right hand side to get x square plus b by a into x equal to minus c by a. Step 4. Add square of half of the coefficient of x, that is b by 2a whole square on both sides to obtain x square plus 2 into b by 2a into x plus b by 2a whole square into x equal to b by 2a whole square minus c by a. Step 5. Write left hand side as a perfect square of a binomial expression and simplify right hand side to get x plus b by 2a whole square equal to b squared minus 4ac by 4a square. Step 6. Take square root of on both sides. X plus b by 2a equal to plus or minus square root of b squared minus 4ac divided by 4a square. Step 7. Obtain the values of x by shifting the constant b by 2a term on right hand side, that is x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Illustrative example. Solve the equation 2x square minus 5x plus 3 equal to 0 by the method of completing square. Dividing throughout by 2 gives x square minus 5 by 2x plus 3 by 2 equal to 0. Gives x square minus 5 by 2x equal to minus 3 by 2. Shifting the constant term on right hand side gives x square minus 2 into 5 by 4 into x plus 5 by 4 whole square equal to 5 by 4 whole square minus 3 by 2. Adding half coefficient of x whole square on both sides gives x minus 5 by 4 whole square equal to 25 by 16 minus 3 by 2 equal to 1 by 16 gives x minus 5 by 4 equal to plus or minus 1 by 4. X minus 5 by 4 equal to plus or minus 1 by 4. X equal to 5 by 4 plus or minus 1 by 4. X equal to 6 by 4 equal to 3 by 2 or x equal to 4 by 4 equal to 1. Hence, the roots of the equation are x equal to 3 by 2 and 1. Quadratic formula method. Steps to find the solution of the given quadratic equation by using the quadratic formula method. First, write the given quadratic equation in standard form ax square plus bx plus c equal to 0. Write the values of a, b and c by comparing the given equation with the standard form. Find the discriminant d equal to b squared minus 4ac. If the value of d is negative, there is no real solution. That is, solution does not exist. If the value of d greater than or equal to 0, then the solution exists. Follow the next step. Put the value of a, b and d in quadratic formula. X equal to minus b plus or minus square root of b squared minus 4ac divided by 2a and get the required roots. Solutions. Illustrative example. Solve for x 9x square plus 7x minus 2 equal to 0 using quadratic formula. Here a is equal to 9, b equals 7 and c equals minus 2. D equals b squared minus 4ac equals 7 square minus 4 into 9 into minus 2 equals 49 plus 72 equals 121 greater than 0. Alpha equals minus b plus square root of d divided by 2a equals minus 7 plus root of 121 divided by 2 into 9 equals minus 7 plus 11 by 18 equals 4 by 18 equals 2 by 9. Beta equals minus b minus root d divided by 2a equals minus 7 minus root of 121 divided by 2 into 9 equals minus 7 minus 11 divided by 18 equals minus 18 by 18 equals minus 1. Nature of roots. The The roots of the quadratic equation ax square plus bx plus c equal to 0 by quadratic formula are given by x equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, where d equal to b squared minus 4ac is called discriminant. The nature of the roots depends upon the value of discriminant d. There are three cases. Case 1, when d greater than 0, that is b squared minus 4ac greater than 0, then the quadratic equation has two distinct roots. Case 2, when d equal to 0, that is b squared minus 4ac equal to 0, then the quadratic equation has two equal roots. Case 3, when d less than 0, then no real roots exist. Illustrative example. Determine the nature of the roots of the following quadratic equation. 2x square plus x minus 1 equal to 0. Here a is equal to 2, b equals 1 and c equals minus 1. d equals b squared minus 4ac equals 1 square minus 4 into 2 into minus 1 equals 1 plus 8 equals 9. Since d greater than 0, therefore the roots of the equation are real and distinct. Illustrative example. Determine the nature of the roots of the following quadratic equation. X square minus 4x plus 4 equal to 0. Here a equal to 1, b equal to minus 4 and c equal to 4. d equals b square minus 4ac equals minus 4 whole square minus 4 into 1 into 4 equals 16 minus 16 equals 0. Since d equals 0, therefore roots of the equation are real and equal. Illustrative example. Determine the nature of the roots of the following quadratic equation. X square plus x plus 1 equal to 0. Here a equal to 1, b equal to 1 and c equal to 1. d equals b squared minus 4ac equals 1 square minus 4 into 1 into 1 equals 1 minus 4 equals minus 3. Since d less than 0, therefore roots of the equation are not real. Thank you. Thank you. No. I know.